Alright guys, today we're going to go over irrigation pipeline design. It was actually my first design when I got here at the NRCS. The field we're going to be designing was located in Los Lunas, and the tools you'll need are Chapter 15 of your Engineering Field Manual, Chapter 3 of your Engineering Field Manual, and the Irrigation Guide. That's all you need. You don't need any fancy Excel spreadsheets. It's all in the Engineering Field Manuals and the Irrigation Guide. Now I will do another video on a spreadsheet we have that you can use, but for now we're just going to do it by hand. The givens: we have 7 acres. The time for irrigation, since it's in Los Lunas, they allot an hour per acre. The crop is an alfalfa. I did the survey, and we have the high water line elevation and the end of the field elevation. And what we're going to find is the flow for a given acreage at 1 hour per acre, the consumptive use of alfalfa for Los Lunas, the available working head, the size of pipe needed to carry the flow, and the pipeline design drawings. What I would require you guys to give during a submittal for irrigation pipeline. To give you more background on the pipeline, we have a main ditch that's currently going through a 15-inch pipe into a open ditch that he wants to put pipe. It goes under a road, entry road. This is the gentleman's house here. And then there's an open ditch here that he wants to convert to a pipeline. We're going to be installing 2 alfalfa valves and running a gated pipe across his field. And for this design purpose, we're going to run it all through 15-inch pipe and see if that'll even work. So the first thing, and then to give you some more background, the main ditch where he's getting his water from is here. I started my survey. This is my little dumpy level. So when you're surveying, you're going to shoot the high water line, the bottom of the ditch, the inlet invert, bottom and top, just so that you can know what the size of the existing head gate is. If not, just take a picture of it. I shoot the top of the ditch on both ends, the end of road, or edge of road, and then I keep on surveying. From there, my dumpy level was about right here. I shot all of this existing ditch, and then I got to the road crossing, and I shot the inlet invert of the existing pipe, the outlet invert of the existing pipe, took note of the size of pipe, and then I shot all in the existing ditch by the field, and I shot about 3 shots on the field. So that's the history on this particular field. And here's yet another layout. We have existing head gate, what the ditch looks like looking upstream, and then the associated values. There's my high water line, my ditch invert, my inlet invert. I've noted this is an existing 15-inch pipe, the outlet invert, the top of ditch elevation, and then the distance from the head gate to the end of the outlet invert of the existing 15-inch PVC pipe, 42 feet. So now we're just going to start the design. The first thing we need to find out is the flow, and you can find that out by using the formula within our irrigation guide. It's the first section of the irrigation guide. The flow, you have to use the following equation: inches per day, so the consumptive use divided by the efficiency of both the field and the delivery method, the acreage, the days between irrigation, and the total hours of irrigation per rotation. We have to find the consumptive use to be able to figure out our total CFS. So if you go into irrigation guide, the consumptive use for both Albuquerque and Los Lunas for alfalfa, using the peak for July, 0.38. Now, most of the people that have been here long enough, they just use the irrigation guide as is, which I do too. I have no issues with that. But if you want to go on to line and go to the irrigation guide that's online, you're going to go to the home page, go to the photog. Oops, wrong one. New Mexico, Santa Fe, whatever. Section 1, you're going to go to reference list. You're going to scroll all the way down to irrigation guide for New Mexico. Then you're going to go to where is it? Consumptive use crops. Then you're going to go down to your respective area, which in our case is Los Lunas. And the peak daily for alfalfa, there's alfalfa, is 0.34. I use 0.38, so I guess you'd leave it to a judgment call on your end. 0.38 is what I used. So when you multiply 0.38 times 7 acres, 14-day rotation, 95% delivery method, which is the pipe, 50% irrigation method, which is flood, and then divide it by 7 acres at 1 hour per acre. You get a staggering 11.2 CFS. That's just not commonsensical, and we're not going to design for that. But if you were to use this, you'd have to have a 2-foot gated entrance or gate valve, head gate, sorry. So I'm just going to go down to 2 hours per acre, and it comes out to be 5.6 CFS. That's what we're going to design for. Now, to find your available working head, all you're going to do is get the high water line elevation, 101.57, subtract that from the end of the pipeline or the end of the field elevation, 92.44. I'm going to get 9.13 feet. That's the available working head. So now we're just going to start designing. All of the charts we're using are from the engineering field manual. So the first one we're going to do, we have to figure out the friction loss due to our design flow of 5.6 CFS. And so we're going to go to the friction loss chart, NM 15-87. It's actually NM 15-14, I'm sorry. It's good to have a straight edge when you're using this. So we're going to go to 15 for 5.86 CFS. You have your flow in GPM, your flow in CFS, your associated pipe sizes, pipe diameters. And so we're going to go to 5.86. And so there's a 6 CFS and a 5.79. We're going to scroll over to 15-inch pipe and go down, and you have 0.39 and you have 0.42, and I interpolated and got 0.36. So that's your friction loss per 100 feet. You also can get your velocity from here. So the velocity through a 15-inch pipe at 6 CFS is 4.9 CFS. So I'm concerned about getting the friction loss, which when you interpolate, I used 0.36. It's between 0.39 and 0.35. So 0.36, it's per 100. Divide that by 100 and multiply by the length of the pipeline, which in this case, the length of the pipeline is 1,079 feet. Just due to friction, you're losing 3.88 feet. So then we're going to go and figure out the loss of the alfalfa valves. So if we're running if we're running 5.6, if the design flow is 5.6 and we're running that through the main line, and we have, you know, alfalfa valve here and the other one's here. Just look at this. One here, one here. 5.6 is running through the main line, but we're not running 5.6 through the gated pipe. If you divide the 5.6 by 2 alfalfa valves, 15-inch alfalfa valves, 5.6 comes out to 2.8 CFS. You have to remember that. So now we're going to use our alfalfa valve friction loss chart, and for 2.8 CFS, when you convert it to GPM, because that's what our alfalfa valve chart is, you get 1257 GPM. So what you're going to do, once again, use a straight edge. We got 1000 GPM here, the GPM on the loss in feet. Diagonally, you have the sizes of your alfalfa valves. We're going to use 15. So there's 1000, we need 1250. So 1100, 1200, 1300. We're going to go in between, and we're going to go across where it hits 15, and it's about right there. And then we're going to shoot down, and we get 0.4 feet of loss due to the alfalfa valve. So there's my 0.4. We're going to have a bonnet. So as per the guidance in the back of this sheet, all you're going to do for the bonnet or hydrant is add another 0.4 to it. And then the last thing to take note of is, what about the losses through the T? This chart takes into account the loss from the pipeline through the T and the alfalfa valve. So we got the loss through the alfalfa valve and the bonnet and the T. The last thing we're going to do is figure out the losses through the gated pipe. And this will necessitate you using Exhibit 1516-2 and Exhibit 15-5. Once again, they can both be found in the engineering field manual. So since we're going to be running 2.8 CFS through the gated pipe, once again, just make sure we're clear on this. We're running 5.6 CFS through the whole pipe, the main pipe. When you open up both these alfalfa valves, divide that flow by 2, you're going to get 2.8 CFS coming out of here and 2.8 CFS coming out of here. So the Exhibit NM15-16-2 gives you the formula for figuring out the friction loss due to outlets, multiple outlets, as being the friction loss due through the gated pipe, assuming the gated pipe doesn't have an outlet, and we're going to be using 12-inch pipe, times F, multiple outlet factor, which you find from Exhibit NM15-5, times the length of your alfalfa valve or your gated pipe divided by 100, plus V squared over 2G. So we're going to figure those out right now. So the first thing, we want to find the friction loss through a 12-inch gated pipe, assuming no outlets. So we're going to do 2.8 CFS. All we're going to do is go once again to our friction loss chart. We're going to find 2.8 CFS. There's a 2.9 and a 2.67. You interpolate, you go across to 12-inch pipe. The friction loss to 12-inch pipe at 2.86 or 2.8 CFS is, I interpolated and got 0.32. So it was between 2.32 and 2.27. I actually didn't interpolate, but we're just going to use it. 0.32 divided by 100 times the total length of the gated pipe is 200 feet. We can cost share, as per what I've been told, on 2 sets of 200 feet of gated pipe. So we're going to do 200 feet. You get due to friction, 0.64 feet of loss. Next thing we're going to do is one set of 200 feet gated pipe has 80 outlets. We figured that out by doing 200 feet divided by the spacing between outlets, 2.5. So 200 by 2.5 is 80. So now we're going to go to our multiple outlet chart to get our next variable, F. We figured out H sub F, it's 0.64, your friction loss through 12-inch gated pipe, assuming no outlets. Then we're going to go figure out our F, and we know that we have the number of outlets and the associated F. We have 80 outlets. The associated F is 0.34, so I have 0.34. The length of one set of gated pipe is 200. Now we have to find V squared over 2G. You can find your velocity also on your friction loss for pipe chart. We're going to go to 2.86 or 2.8. And for 12-inch pipe, the velocity, if you go down, is, I used 2.5. So let's see, where's 2.5? Oops, sorry, not 2.5, 3.55. So I interpolated between 3.4 and 3.6. There's not a 2.8 on there, it's 2.9, 2.67. So I got 3.5. That's what I used. So all I did for V squared over 2G was I put 3.55 divided by 2 times 32.2, and I got 0.19. So now I have all three variables. I have H sub F, F, Al, V squared over 2G. We're going to plug those in. We're going to get our 0.64, the friction loss through the gated pipe, 12-inch gated pipe. There's our F, 0.34. This length, Al, is 200 feet of gated pipe divided by 100, so that's 2. And finally, V squared over 2G came out to be 0.19. When you add and subtract, or add and multiply all that, you're going to get 0.625 feet